Welcome to lesson 05-2, factoring algorithm. So we're going to develop an algorithm in order to help us figure out if something is factorable or not. So this should be, for those of you that have taken Algebra 2, should be a little bit of a throwback to see if you remember how to factor and what factoring is. All right, let's get to it. So what we're going to do is we're going to create a program that asks a user to give a natural number. So this is an integer that's greater than zero. And as a reminder, integers are whole numbers. So it has to be a whole number that's greater than zero that actually exists, right? Okay, so the program is then going to give the user the first factor that exists for that besides, one isn't a factor, but it seems like it would, and we have to pay attention to that. Or we have to let the user know that that number that they're utilizing is prime. So in order to develop this program, we're going to have to learn about interactive programs, how data entry works in Scratch, and kind of a way of doing factoring that some of you may be familiar with, but I would imagine a lot of you aren't. So, an interactive program, and we talked about this in the last lesson too. This is a program where it receives information from a user, and a lot of times this comes in the way of data, and we modify that data and we send that data. We send the data that we process back to the user, and this is something that interacts with the users, and it lets it know it's running, or it kind of waits for user input in order to actually operate. It can't operate without it. A lot of things that we've done up to this point, we just hit the go button and we watch what happens. So this is what happens whenever we talk about a search engine. It's also what we talk about whenever we kind of have, at a kind of different level of video game or something like that. They all have this kind of user interaction. So what happens in search engines is you enter what you want, they process that information, they find websites or articles or whatever that match, and it sends you back those results. So and for you to use to enter data in a way that Scratch can actually process it, we have to go to sensing, and we have to select the ask button, and it's that ask script. So if I switch over, and I was supposed to show you that, oh well, it's fine. It's not like it's super sensitive data. So I go right over here to, I always like to do events so that then I don't get myself mixed up, and ask, what's your name? And the answer, which is right underneath it, is going to have that data saved for us. And like we've seen on with other variables, if we click this little checkbox, it'll actually show what we've typed in there. So if I click the green box, it's going to say, what's your name? And I'm going to say Datrix, and it's not going to do anything with it. And I expected that. All right, so let's go ahead and experiment with it. Let's make it so it actually says my name back to me. So here we go. So the green flag is clicked. Ask, what's your name? And I'm going to say have Scratch say hello to me. Now, I can just do hello, but again, it's going to ask, what's your name? I'm going to say Datrix again, and it's just going to say hello. It's not going to say anything about Datrix. Well, I want him to say Datrix. So I'm going to go here into operators and put a little join right here, and I'm going to then say hello, comma, or not a comma, hello, and then do a little space to make it look nice, and then sensing, grab answer, and plug it in. What's your name? Datrix. Hello, Datrix. Hi, Scratch. All right. So let's jump back to it. So let's go ahead and start to modify this in a way that actually works for our program. It's fun to do these kind of side things, but we want it to really be kind of what we're interested in. So let's change this up a little bit. Let's say enter a natural number. I kind of think a little bit robot-y. Enter a natural number. And then it's going to say the number is, and then the answer. So if I put play, enter a natural number, let's say 15. The number is 15. Awesome. Cool. Now, one thing that you'll notice with this is that it is possible to still currently put like 13.2, and it's not going to notice anything. We're not going to build any type of detection system for this to tell if it's a natural number or not, but for the most part, like, you can definitely take it that step further and do that. But we're not going to do that necessarily in this class. So let's go ahead and switch. And all right. So prime factors. These are factors that are numbers that are the numbers that divide evenly into a number. 4 is a factor of 12 because 12 divided by 4 is 3. There's no remainder. And that's actually a really important part, is that we don't have this remainder. Now, as I said, natural numbers are integers that are greater than 1. And these are whole numbers. And so the prime factor of a natural number are the integers greater than 1 that divide evenly into the given number. So if a number divides evenly or with no remainders, nothing else, then it's a factor. So to find the factors of a number, we need to understand what's called the modulus function. Now, for those of you that maybe are in 4th grade or took 4th grade, you may, and it might be an earlier grade than that or a later grade than that, you will probably remember long division. And in long division, you actually had remainders. And that's kind of the big thing of the modulus function, is it actually gives us the remainders. So the modulus function, yeah, it gives us a remainder when a number is divided by another number. So here's an example for you. 10 modulus 5 is 0. The reason why is 10 divided by 5 is 2, but there's no remainders. And that's what we're looking at there, is we're looking at the no remainders. Example 2, we have 10 modulus 6, and that gives us 4. Because 10 divided by 6, 6 only goes into 10 once evenly, and then it has 4 left over. And so the result that we get in a modulus is how many are left over. All right. So this is what we're going to use in order to help determine if a number divides evenly into the other. And this will help us figure out the factors, because with a factor, it has to go in evenly. All right, so let's just kind of do this by hand real quick. So find the first factor of 35. So what times something besides 1? 1 and 35 doesn't count. What number after 1 can go evenly into 35? Well, 1 can't, 2 can't, 3 can't, 4 can't, 5 can't. It ends in a 5. For those of you know that you know your math facts, 5 can go into a 5. All right, so we did those. Hey, that actually works. So 5 is the first factor of 35. All right, so let's go ahead and start programming this a little bit. Just kind of wrap our heads around it. As always, let's go ahead and do our initial setup. Just kind of get everything started. So we want to save this number. This gets overwritten if we ever write an ask, do another ask. So let's go ahead and make a variable, so then it actually gets stored. And this variable, we're going to go ahead and call, let's just call it number. That's just easier. Number. All right. So we make things. The number is the number. Oh, yay, woohoo! But let's go ahead and set that to be the answer. And you know what? We don't really need this anymore. Who do not want to delete 2 blocks? I want to delete that. All right. And then let's go ahead and set factor choice. Let's make one called factor choice. Factor choice. And we're going to set factor choice. And we're going to set it where it always starts with 2, because otherwise 1 would just always work. So we're going to set it to 2. All right, so let's set the factor choice to 2. Now we need to go and make a modulus function that gives us the remainder. So if I go to my operators, if I go here and grab this, I want it to be equal to 0. Now I need to go find this modulus function. And let's think about something that we talked about. Let's do 10 modulus 5 and see what we get for this result. We get a true answer. What if I did 4? Then I get a false answer. Okay, that's what we want. I'm just going to put 5 in there for now because we can see it. Let's just kind of fill these things in for it. So answer is the number that we want to try and figure out, which is, I was going to call it number. Answer is the value that we get, so let's put number in for 10, and then factor choice in for 5. Ooh. Oh, because we haven't provided a number. I was thinking that was 10. Yeah. So we haven't provided a number yet to it. So it's currently is false because it doesn't have a remainder of that. That's okay. That's cool. All right. So let's go ahead and make a little script for this. And what we're going to do is we're going to make it check on if it's if it is or not. So what we're going to do is, let's go grab an if statement. If this is true. So if it's modulus, then we want it to say, and we're going to use some joins here. We're going to say factor choice, because that's the number that's dividing into it. I think I'm going to need some more joins. Let's throw another join on there. It's easy to take them off. It's kind of annoying to put them on. Put a space beforehand because it doesn't automatically put that in there. Is a factor of, I guess I didn't need the last one. Then let's take that right here and put a number. All right. This is not a true statement right now. So let's see here. Let's get a number in there. Let's do 10 because I know 10 works. So right now number is set to 10. If number, so 10, divided by 2 has no remainders, then it's going to say this. Hey, it said it. All right, let's just make sure that wasn't a fluke. Let's go ahead and make this 11. And if I click on this, it doesn't do anything because it wasn't a true statement. So it's like, nope, not a thing. All right, awesome, cool. That's what we wanted. All right, so let's build another factor. So when it's not a factor, let's increase the factor choice by 1. So if it's not true, we're going to change factor choice by 1. If 2 doesn't work, then does 3, does 4, does 5, does 6, and we'll go ahead and we can check that. Now, one thing I want to do is I want to kind of set a point where it's going to stop, because if I run this right now, let's just say I put it inside of like a forever loop. I said forever. This would never end, because even if it got past 11 and we as humans know that wouldn't work, it would still think like, oh, I'm just going to keep checking these. So I don't want to do a forever loop. I want to instead use a repeat until. And what I want to repeat it until is until my number and my oops, I don't need that. My number and my factor choice are the same value. Because if I go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, obviously when I get to 11, 11's going to go into 11. And so if that's the case, I kind of want to end it. So let's put this right here and see if we can get a result. Let's use a number that works. So what divided by 2? 10 is an option. 2 is a factor of 10. Awesome. Oops. I forgot to put something in there. I forgot to put that once this completes, it's going to leave that. We want it to leave this right here. So we want to go and I want to stop all. If we get the answer, once Scratch says it, I want to stop everything. All right, let's try that again. So if I go 10, 2 is a factor of 10. That's it. It doesn't keep going. I can see that on the factor choice. Let's try another one. Let's try a number that doesn't work with 2. So an odd number. Let's go with 15, not 150. 15. And hit play. 3 is a factor of 15. Okay, so that means it went past it. Awesome. Went past 2 at least. All right, let's try a number that is prime. So let's go with 11. And he says nothing because it got all the way up to 11 and then it stopped. All right, so let's figure out what to do there. So let's make it so that he would say it's prime at that point. So if it makes it all the way through here, we're going to say it's prime. So look, say, let's put a join. And let's do the number, because that's what we're looking at. variable, number space is prime. All right, let's try 11 again. 11 is prime. Awesome. All right. Now, the question that I kind of have for this is going all the way up to the existing number is a lot of work. It's a lot of data. And right now we're just working with small numbers. That's fine. But is there a way, could there potentially be a way that we could work at a smaller, like use less numbers and so we could find our answer quicker? And the answer to that question is, well, yes. And what we have to think about is, for those of you that have taken Algebra 2, is you might remember like the factoring, like, I don't know if it's a chart, it's not a tree, but where you can kind of go like 1 and 20, 2 and 10, 4 and 5, 4, and then you kind of like, oh, I'm at 5, so I'm done. So let's take the same idea. We want to say, oh, well, if it goes past half of the number, then it can't come back. So we're going to change this up and say if it's the if the factor choice is equal to the number divided by 2, and I guess I could have left that around. Let's see here. Oh, yeah. Though this is going to make... I want to make that so that it takes care of any rounded things. Okay, so I'm going to make it so it rounds it, because if that way so it'll be like 0.5, and so it'll round it up, so it'll at least go to, like, if I'm thinking like 22, it's going to go at least to 11, or 23, it's going to go at least to 12, so then it's able to get past that halfway point. All right, because if it's a decimal, then it's going to be not great. Okay, so let's go ahead and give this a shot. And it's not going to be something that we really necessarily see. 11 is prime, yeah, sure. Let's do with 430, I don't even know if this is prime. Oh, 19 is a factor of 437. Well, learn something new every day. Just trying to make something up that would work. So this is really kind of more, it's quicker. And actually, there's an even faster way. And the way to do that is, instead of finding the number, it actually goes even so far as, if we think about 16, the farthest factor of 16 that we have is, so we got 1 in, or for the first factor, we have 1 in 16, we have 2 and 8, we have 4 and 4. 4 and 4, they're right next to each other. Well, what's 4 and 4? It's actually the square root. It's actually the square root of the number. Actually, change this around, grab a greater than, repeat until factor choice is the square root of the number. Now I can toss that. Square root. And if I hit play, hit a natural number, let's say 16. 2 is a factor, okay, no big surprise. 27, 3 is a factor. 11 is prime, awesome. All right, now what you need to do is, for the assignment, is make this into a procedure. And so what you get is you get 2 things, and I can actually show you the assignments list here. Is we just did this actually. But we'll go ahead and make the initial program. So this is all that you get to have when the green flag is clicked. You get to ask for a natural number and weight, and then you have to factor the answer. Now remember, you're going to have some kind of factoring procedure. I would probably put number as a parameter, and then make sure you comment on all your code. All right. Hopefully you had a good one.